You know, when you hear the phrase remote-controlled camera, you probably picture those grainy security domes on a ceiling.
Oh yeah, with that super jerky pan and blurry zoom.
Exactly.
Yeah.
You're lucky if you could even recognize a face on that footage. But today, we're looking at a $6,495 piece of hardware from HDTVSupply.
Which is a serious investment.
It really is. It takes that standard physical frame and just, like, injects it with Hollywood-grade optics and VR tracking tech. Welcome to today's deep dive, where we are unpacking the Bolin Technology R9-418NW.
This specific pan-tilt zoom, or PTZ camera, it's essentially the blueprint for the future of virtual broadcasting.
And to understand why it commands that kind of price tag, we really have to look at the physical foundation driving it, right?
Right, starting with the image sensor, because raw image quality dictates literally everything else downstream.
So diving into the specs, this camera is packing a Sony 1-inch 4K CMOS sensor with 14.2 effective megapixels.
Which is massive for a PTZ.
Yeah, and it's paired with a Zeiss Variosonar T-lens doing 18x optical zoom in 4K. I mean, it's like taking a high-performance supercar engine and dropping it straight into a remote-controlled chassis.
That's a great analogy. The crucial detail there is really the 1-inch sensor. Standard PTZ cameras usually rely on much smaller sensors.
Which struggle in less than perfect lighting, right?
Exactly. They struggle with light, and they just flatten the resulting image. But stepping up to a 1-inch sensor allows this camera to capture a massive amount of light and a true cinematic depth of field.
So it physically separates the subject from the background.
Yes, which is a hard requirement for ultra-high-definition broadcast quality.
Well, having a massive sensor is great for optical quality, but, I mean, raw image fidelity doesn't really help if the camera can't communicate with a modern digital broadcast environment.
Right, the software side of things.
Yeah. The sources highlight that the R9 integrates the Freed protocol for VR and AR video production. But wait, I have to push back a little here.
Okay, go for it.
Motion tracking isn't exactly new. Like, my smartphone can follow my face on a video call. What is a $6,500 rig doing that a basic AI webcam isn't?
That's a fair question. So a smartphone webcam uses software to artificially crop and pan within a static wide-angle image.
So the camera itself isn't actually moving.
Exactly. The Freed protocol does something entirely different. It acts as a spatial translator for the physical hardware. The camera is constantly reading the micro movements of its own physical pan, tilt, and zoom servo motors.
Okay, and then doing what with that?
Translating those mechanical positions into exact 3D coordinates.
Oh, wow. So it's actively feeding that precise X, Y, and Z coordinate data directly into the broadcast software in real time.
Yes, and that solves a massive real-world broadcast crisis. Imagine a live presenter walking across a physical green screen while a virtual 3D city is rendered behind them.
If the camera pans to follow the presenter, the background has to match.
Right. The virtual background has to move in perfect, frame-accurate sync, or the entire illusion just shatters. Freed automates that complex synchronization without needing a human camera crew physically maneuvering a tracking rig.
Okay, but if you're calculating all that mechanical data and capturing a massive 4K VR feed simultaneously, how do you route all that back to a control room without just, choking the camera's processor?
That is where the true tri-output capability comes in.
Yeah, the specs call that out, pushing out SDI, HDMI, and IP signals in independent formats. It sounds less like a multi-lane highway and more like a massive digital switchboard.
That's exactly what it is.
Like you can pull a 4K stream for the virtual set, a 1080p feed for a live studio monitor, and an SDI feed for the archives, all simultaneously.
And that switchboard capability is what prevents production bottlenecks. Plus, when it comes to that IP stream, the camera supports NDI 6 ready and HX3.
Which is a big deal in the broadcast world.
Huge. It means you are transmitting visually lossless 4K video over standard local networks without the crippling lag you would normally get.
Which perfectly explains the control compatibilities listed here. Things like VSCA over IP, ONVIF, and Pelco.
Right, those are the industry standard languages control rooms use to talk to remote cameras. By combining those control protocols with the uncompressed NDI HX3 video, this camera drops seamlessly into major broadcast ecosystems like TriCaster or vMix.
So a technical director can control the camera, pull the 4K feed, and render the virtual set all over a single network cable with ultra-low latency.
It's incredible efficiency.
So ultimately, the Bolin R9 isn't just capturing video for you, it's serving as a robotic bridge, seamlessly tuning physical studio space into digital data for AR environments.
Yeah, it takes the traditional static broadcast studio and makes it completely modular and automated.
Which leaves me with a final thought for you to ponder. If this kind of automated VR-ready tracking precision, this remote-controlled supercar costs 6.5 grand for professional broadcasters today, how long until this exact free spatial technology becomes the standard in the devices sitting right in our own living rooms?